Okay, so this video is an introductory video on using FormIt for simulation. It's specifically pre-design simulation. So simulation as a part of the design process where we are still trying to figure out exactly what the design should do. So we're continuing to work with this site that my students selected in the Himalayas for me just to make things super complicated. Super hilly terrain. One of the first things I'm going to do just to make this process work easier for me is I'm going to go back down to just the satellite image. Let's reduce the terrain so we can work just on the XY plane, keep things flat, keep things visually simple, just so we can be looking at building data. Okay, so what we're working through are just a really simple form, really simple, very small building. So we're not going to see dramatic results on the simulations, but you're going to get an idea of, if something changes by 0.2% or even a full percent for something that is 2,000 square feet, if we imagine that in a 20,000 square foot or 100,000 square foot building, all of a sudden we're talking dramatic changes in terms of energy use and cost. So understanding it at the small scale is certainly going to apply to a larger scale. So the first thing that we want to do is understand BTUs per surface on a design. So to do that, that's going to be found underneath the Sun tab right here. And we are going to turn on solar analysis. Now you have to have imported your weather station data. So make sure that as you are building this, as you're looking at your site, you've selected a weather data station. We've covered that in a different video. So that should be good to go. When you launch this tool, it might tell you, if it's not part of your file yet, that might be part of what you're seeing is please wait while we download the weather data. We've got two methods, year cumulative and month peak. For me personally, year cumulative is very useful if I want to think about solar panels, like how much solar energy is going to happen on a surface over the course of the year so I can optimize that. Month peak is more about, for me anyway, it's more about understanding worst case scenarios or best case scenarios. How this in the Himalayas, how could I go to a month where it is colder? How could I find an area where I can optimize solar heat gain by increasing the amount of glass or something like that on a facade? So if I look at, let's just go to December. And let's look at selecting all the surfaces. So if you notice, nothing is happening yet, but my prompt here is select faces or objects, then click Analyze. So I'm going to select all the objects just by a double click and then run Analyze. And now I get BTUs per surface. So in looking at this, obviously I've just a shade more on my south. If I hover over, I'll see 207 BTUs per square foot. As opposed to the roof, 172, which is really interesting. I mean, you don't see that at a lot of different times of years and a lot of locations where one of the walls is actually going to be higher in terms of the BTUs than the roof. So trippy, cool, love it. And then we've got our sides, and obviously we get to the north facade, and we're down to next to nothing because there's very little daylight hitting that surface in December as my month peak. So really useful information. I can change that to a different time of year, and it's going to automatically update and give me the results, which again is, it's really interesting on the dramatic changes on the results on this one. Now we're seeing 300, close to 300 BTUs on the roof, but then I'm going to, let's go back to that south facade again. Yeah, and we're down to nothing now, again, on this facade. So really, really interesting to watch this work and get an understanding of how much solar energy is hitting each surface of the design. And that way we can start thinking about how we orient, where we might want to have more glass, more exposed surfaces, where we might want to have overhangs, those kind of things to help protect those surfaces. So that's specifically looking at solar gain. I'm going to check box out of that. The next thing we want to run is a full energy analysis. So our energy analysis is in two steps. The first thing that we need to do is we need to tell FormIt that this is, in fact, a building because right now it's just a six-sided box, right? So to do that, I'm going to select all of it. So lasso select, or I can double click. And it knows we're right now we're doing this just off of a massing form, right? Just a very, very simple massing form. Um, Again, we're thinking about pre-design simulation. I don't have any windows decided yet. I don't have my roof form decided yet. None of those things are in place. But the Insight tool set that we're going to next will actually create a lot of design variables for us that then I can push back into FormIt in terms of making informed design decisions about number of windows, orientation of the building, all of those things. So to define that this is a building, I need to go to this object's properties. So I've already put it on a layer called building, which is good. You don't have to do that. And then the next thing that I've done is checkbox right here, use levels. Now you'll notice I can, there's a tool where I can build more levels, things like that. But what I'm really looking for, this is a single level. So, I'm not going to check here 2 levels. It's just a single level located at 0, which is where I'm modeling at. And you can see sort of this little blue outline right here that is signifying that. And it's now identifying this is a 2,400 square foot building. So this knows that now if I go here and click Generate Insight, that this is going to build an energy model for me in the cloud. So essentially, we're going to click Generate Insight. And this takes a little bit of time to upload, even though it's a simple building, because it's taking a lot of data with it in terms of location. It's getting you in the queue to run an insight. And usually after a few minutes, it does take just a little bit of time, you'll be able to click View Insight. And that should take you through your web browser to this particular form. And by form, I mean web page, okay? So this is going to generate what are called insight tiles. And all of these are design options. And what these are going to do for you is illuminate for you exactly what changes you might make that are going to improve the overall building energy. And the best way to watch that is this tile right here. So our ASHRAE 90.1, this is our standard. This is what we currently have to meet. So you can think of this as really the lowest common denominator. I have to be under this bar. But obviously what we're wanting to do is see if we can push this to a more efficient number. This next tile is simply going to give you design options, right? So as I build different variants on this, or different variables as I apply them, how can I start to really work through what my potential is? So let's just buzz through a few of the tiles. I'm not going to go through all of them, but let's take a look. So if I flip building orientation, I'm almost a completely square building. So you're not going to see a lot of variation on this. So a reduction of -10 US dollars per meter square per year. So not a lot of drama there. If this was a different size building, we might see something a little bit different. On these, so this is degrees of orientation off of 0. In each of these tiles, you will also see a BIM set right here. So BIM is if I'm importing BIM data. So specifically for my class, we're not using that. So, sometimes that's going to look like a better option. It's not an available option for you until you get a little bit more advanced and you're importing BIM data as an option for this. Okay, so let's flip that back over. And again, it makes sense. I'm a fairly rectangular, almost square design, so orientation is not going to make a big difference. And you'll also notice I have the exact same amount of windows on each facade. So as the simulation was started, FormIt's basically making an assumption. Well, it's not going to be a solid box. There's going to be windows. So I'm just going to give you a default value for each side for windows. Okay, so let's scroll on down a little bit. So right now we're seeing window to wall ratio for the southern wall. If I flip that tile over, you'll notice, okay, this is going to have a little bit more of an impact. So this is where we start balancing out, well, I've got great views to the south, but I also need shut the windows down, the window to wall ratio down, rather than it being closer to 95%, maybe I should drop it, more like 30%, so that I can get a little bit of cost savings for this. Okay, so to work with those variables, I'm simply selecting that, and I have these sliders that I can bring down. And so let's establish that as a 30%. And you can see it's automatically updating this cost calculator. So again, if I scroll that back up, you can see right now we were at 16.8. By being a little bit more specific and saying, well, I'm going to hold that to a 30% window to wall ratio, I'm actually starting to see a small energy savings. And that's a good thing, right? It's not a big jump for sure, but if this is a larger building, those small percentages are going to add up in terms of energy savings really fast. Next, if I look at window shades, right? So if I scroll back up, I should start seeing an update here. I'm not yet, it doesn't look like. Let's change that to none, and let's see if we get an update. So if I drop that to nothing and scroll back up, well, I guess it's not updating. We'll have to look and see if there's a way to update that. I kind of thought that would automatically update, but it's not. Set that back to 30 because 0 is unreasonable for this particular model, this particular design. So shades, I know that in a lot of locations, if I do a little bit of solar shading, a little bit of an overhang, especially along that south side, that I can get some savings. So let's just crunch that in. And then let's look at the type of glass. So if I flip this, you'll notice, again, this is such a small building that I'm not seeing big changes. But if I go to a triple low E glass, it's definitely picking up a little bit of energy savings on that south facade. So essentially, I'm going to go through and work through all of those on the glass, each facade, seeing what's making a difference and seeing what's not. If I come down to wall construction, you'll notice that right now it is an uninsulated wall. And this is where we should start to see some better savings here, right? So just looking at this, we can go to an R38 wood as an option for a small residential project. Makes a lot of sense to think about that as something that's reasonably easy. And then also if we look at roof construction, we're seeing, much larger savings on this. So, for this zone, it's really interesting to see not a huge jump between R38 and R60 as my insulated value here. So let's just crunch that into an R38 to R50. And window infiltration. So this is, again, some basic design specification standards. So we can crunch that in and say, yes, we're going to make sure this is done right, spec'd right. Lighting efficiency, same thing. This is, again, we're looking at how many watts per meter squared that our lighting is using. So if we go with, a reasonable kind of lighting system on the inside, and then daylighting controls. This is tricky. We're a house, right? So, we have to kind of assume that this is sort of a 24/7 occupancy. If it was an office building, something like that, we might have a little bit of a different take on it. But this is, if we have some basic daylighting controls and occupancy controls, we'll see some savings on that. So I'm just going to sort of leave that range a little bit open, but let's go to that. Plug load efficiency, sort of same thing. Again, we're looking at how efficient devices that we have on the interior. So yeah, well, we want to do that too. Why wouldn't I want to do that? Let's get that someplace again in the middle for what our standards are going to be. HVAC, again, we're seeing, for a project this size, again, we are seeing some really good jumps. Now, if you don't know what you're specifying here, it is important to look into this a little bit. Because again, for a small residence, it might not make a lot of sense to have, a really, really high-end, uber high-end kind of system. It just might not be reasonable, because we're not going to get the payback perhaps on a smaller building. But you're definitely seeing some pretty dramatic drops in terms of the HVAC system. So let's get an ASHRAE package right here. Let's do something a little bit more middle of the road as we're defining it. And then operating schedule. Well, this is a house. And I've always found this really interesting. So people are one of the biggest deciding factors in energy. And when you think about it, it makes a ton of sense. But it's a house, so really we're back to here. We're 24/7. And you can see that cost goes right up really fast. But that's the reality of a house. It is pretty much a 24/7 thing. If we know the lifestyle of the human and know they're going to be gone during the day, and we can really optimize the controls for the house, then we have a dramatic saving. So it's a really interesting thing to work at and look at with the client in terms of where we can provide savings in terms of what we specify. Can we install a system that helps the occupancy understand what's going to happen and optimize an operating schedule for the primary systems in the house? So let's kind of crunch that in. Might not be realistic. Then we've got a few things like solar panels in terms of what we can add. This is looking simply at when, as we optimize different things, if we're willing to invest more in more efficient things that have a longer payback time. In other words, we're paying more for more optimization, and we're willing to allow those things to have a 30-year payback. We actually do save more in the long run in terms of cost per meter square per year. But I'm going to leave that as it is. And then solar panels. What can we start doing in terms of different levels of efficiency on our solar panels on the roof? And so let's definitely add some in, and we'll get a little bit of savings going there. So after flipping through all those tiles, you can see that we're starting to update this number right here. We're building a better range. We can start to see a breakdown of these different options each time we've changed a variable on this. It's reflected in this model history in terms of the range of how the design is going to perform. So that's the basic. That's our basic intro in terms of how this system is working, what information we can glean from it, and how we can use it as a pre-design simulation tool.